Good morning, students. We've already finished how to prepare hydrogen in laboratory, then the various other methods of preparation. Then we went on to study the physical properties and the chemical properties of hydrogen. Today, we are going to deal with only exclusive property, and that is hydrogen gas as a reducing agent. Hydrogen gas has got strong affinity to remove oxygen from metallic oxides, reduce it to corresponding metal, and water is given off. So hydrogen has the property to remove oxygen from strongly heated metal oxides when passed over them, and itself hydrogen gas gets oxidized to water. Now let us quickly take a look at some of the metallic oxides. For instance, ferric oxide, heated ferric oxide. When you pass hydrogen gas over it, you get metal iron and water is formed. Now what have you observed? The color initially of ferric oxide was brown, okay? Later on you'll see it turns into gray in color due to the formation of iron. Similarly, heated lead oxide when reacted with hydrogen gas gives you the metal lead and water. So lead oxide, initially it was yellow in color, it turns into silvery gray metal lead. And the third example, cupric oxide, okay, which is pitch black in color. When heated and hydrogen gas is passed over it, you'll see that a reddish brown metal copper is left behind and water is formed. So these are few important examples of reducing action of hydrogen, okay, especially with reference to metallic oxides. Now, we have studied in the past what is hydrogenation, but still I would like to revise once more. Hydrogenation is addition of hydrogen to organic compounds in the presence of a catalyst, for example, platinum or nickel on heating. Let's take an example. Acetylene gas is the formula is C2H2. When you react with hydrogen gas in presence of catalyst nickel and heat it to a temperature of around 300 degrees Celsius, it gives you ethylene gas, and that is C2H4. What is happening? Addition of hydrogen to acetylene, and thus ethylene is formed, C2H4. The second example, ethylene, that is C2H4. So ethylene gas, when reacted with hydrogen in presence of catalyst nickel at a temperature of 300 degrees Celsius, it gives a saturated hydrocarbon ethane, and that is. Last of all, what is hydrogenation of vegetable oils? You have studied in class 7, class 8 as well. Still then, let us revise once more. Hydrogenation of vegetable oil. On passage of hydrogen through vegetable oil in the presence of a catalyst nickel at high pressure and at a temperature of 200 degrees Celsius forms solid or semi-solid vanaspati ghee. That means when you pass hydrogen gas over liquid vegetable oil in the presence of a catalyst nickel, okay, and it has to be at a high pressure and at an elevated temperature, what does it form? It forms solid or semi-solid vanaspati ghee. That brings us to the end of today's lesson. Please revise the lesson and then you answer the questions that are given to you in the assignment. Thank you.